Welcome to Crypto 101, a first principles jargon-free course on blockchain and its impact on financial services. In this lesson, we will learn about Ethereum, the second oldest blockchain network after the Bitcoin network. We will learn about the similarities between the Bitcoin and Ethereum networks as well as the differences. Before we begin learning about Ethereum, let us recap from the previous lesson what a blockchain is. A blockchain network is a network of computers that store the same information concurrently by propagating information to each other, and operate by a set of rules that is encoded in software specific to that network. The term blockchain technology refers to a set of technologies and software enforced rules that are brought together to perform certain functions. The Bitcoin and Ethereum networks are both blockchain networks built with blockchain technology. The Bitcoin blockchain network was started in 2009. The Ethereum blockchain network was started in 2015. In this lesson, we will learn how Ethereum and Bitcoin are similar and how they are different. The blockchain address within the Ethereum network is called the Ethereum address. Ethereum addresses are of two types. First, externally owned accounts. These are just like Bitcoin addresses in that they store the value of cryptocurrency. For simplicity, we will call them currency addresses. Later we will learn why they are called externally owned accounts. The second type of Ethereum addresses are contract addresses. They store software code called smart contracts. The use of the expression smart contracts is confusing since the term contract presumes a legal agreement between parties. A smart contract is simply a software code that performs a programmed action. For instance, you could code a program that calculates the square of a number and place the code in an Ethereum address. We will cover the purpose of placing software code in an Ethereum address in a later lesson. Just like Bitcoin transactions, Ethereum transactions have a source and the destination address. In Bitcoin, the source and destination address are always currency addresses. The only thing that moves between source and destination is currency, which is Bitcoin. But in Ethereum, the source and destination could be either a currency or a contract address. In the next section, we will delve deeper into Ethereum transactions. Ethereum transactions are broadly of two types: payment transactions and contract transactions. Next, let us look at what these are. The purpose of payment transactions is solely to make payments. These transactions transfer Ether from one address to another. The source and destination addresses are both currency addresses. Payment transactions are conceptually identical to Bitcoin payments. Contract transactions either create a new contract address containing a smart contract or trigger the execution of an existing contract. In such transactions, the destination is always a contract address while the source could be either a contract address or currency address. There is no counterpart of such transactions in Bitcoin. Ether is the native currency of the Ethereum blockchain, just like Bitcoin is the currency of Bitcoin blockchain. The smallest unit of USD is 1 cent. The smallest unit of Bitcoin is Satoshi. 100 million Satoshis is 1 BTC. The smallest unit of Ether is Wei. 10 to the power 18 Weis is 1 Ether. As we continue learning about Ethereum transactions, we can now take a step back and define transactions on the blockchain in a very generic way. A transaction allows a user to effect a change in the information being stored in the blockchain network. For instance, a Bitcoin transaction adds a new payment record on the Bitcoin blockchain. The attributes of a transaction refer to the information contained in the transaction. Both Bitcoin and Ethereum transactions have a set of attributes. Examples include the value to be transferred, the date of the transaction, the destination address. There are two attributes of Ethereum transactions that are highly relevant in understanding the difference between Bitcoin and Ethereum. Value refers to the amount of the network's currency being transferred to the destination address via the transaction. This attribute is equivalent to the payment amount of a Bitcoin transaction. Data refers to any type of information. There is no identical counterpart in Bitcoin. Next, we will look at this element further. The data contained in the transaction may simply be informational. For instance, when you write a rent check, you may quote your apartment number on it. In the same vein, you can write in a note on an Ethereum payment stating the purpose of payment. No response is triggered in the Ethereum blockchain, just as the bank doesn't care about the apartment number written on a rent check. However, there are two situations where the data field triggers a programmatic response on Ethereum. The data attribute of a transaction can include instructions to create a new smart contract. The data attribute of a transaction can also include instructions to trigger the execution of a smart contract that already exists. Next, we will look at examples of 2 and 3 above. Consider a simple software code that does the following. It defines a variable called x and sets its value at 0. If defines two possible input instructions. An input of increase means that x will increase by 1. Hence, if x is 0 and it receives an input of increase, it will become 1. If it receives a second input, it will become 2. An input of decrease means that it decreases by 1. At this point, all that is being done is that a code is being written. We can give a name to this piece of software code. We call this the user count program. Programmers write code in human-readable format in a programming language designed for Ethereum and is converted to machine-readable code by specialized tools. The code is contained in the data attribute of the transaction. You may be curious as to what a code actually looks like in Ethereum. Below is an example. The code is machine-readable and not human-readable. The programmer sends the transaction from his Ethereum address to a special address, known as zero address. A transaction received at this address conveys to Ethereum that a new contract needs to be registered. The result is the creation of a new Ethereum contract address. Let us denote the resulting Ethereum address by capital C. The contract stored in this address remains dormant unless it is executed by a transaction. Next, we will learn about such contract triggering transactions. The contract address, C, in our example, contains two pieces of data. First, it contains the software code. Second, it contains the value of x, which as of now is 0. The data attribute in an Ethereum transaction can be used to trigger a pre-existing smart contract. We will continue with our previous example. A streaming service similar to Netflix wants to publicly report the number of its subscribers on a real-time basis. The contract address C is actually owned by the streaming company. Every time a user signs up online for the service, behind the scenes, an automated transaction is sent to the contract address C with the instruction to increase x. The value of x keeps increasing by 1 on every sign-up. Every time a user cancels the service online, behind the scenes, an automated transaction is sent to the contract address C with the instruction to decrease. The value of x keeps decreasing by 1 on every cancellation. At any time, each node on the Ethereum blockchain reports the value of x, which represents the number of subscribers to the streaming service. Advertisers use this data to determine whether they should be advertising on this service. Investors use this data to determine whether they should buy or sell the shares of this streaming company. Is this a good use of the Ethereum smart contract functionality? After all, the streaming company could broadcast the number of subscribers in many different ways, including sending an Excel file to advertisers and investors. We don't need to worry about this question right now. All we are trying to understand with this example is how an Ethereum transaction involving a smart contract works. We can now identify three types of outcomes that can be triggered by an Ethereum transaction. 1. The outcome could be a transfer of currency from one address to another. This is identical to a Bitcoin payment. Second, the outcome could be creation of a new smart contract. Third, the outcome could be triggering of an existing smart contract. In the second and third types, the data attribute of a transaction is used. To effect a transfer of currency between addresses, the Ethereum transaction uses the value attribute. Think of it as an analog of the amount field on a check. To effect creation of a code or execution of a code, the Ethereum transaction uses the data attribute. Think of it as a place on a check where you can write any additional information. The difference, of course, is that in an Ethereum transaction, what you write on the data attribute may not simply be informational. It could create or execute software code. We can now summarize the differences between Bitcoin and Ethereum we have learnt so far. The blockchain address in Bitcoin can only hold value of unspent currency. Ethereum addresses can contain three types of information. First, the value of unspent currency. Second, software code, also called smart contract. Third, the outcome of the execution of the smart contract. In our example, it was a number representing the number of subscribers. Bitcoin transactions only transfer currency values between addresses. In Ethereum, a transaction can transfer currency values, register a new smart contract, or trigger an existing contract. We can synthesize the difference between Bitcoin and Ethereum to a higher level. Both Bitcoin and Ethereum networks use the underlying technologies that are collectively termed as blockchain. But the purpose of the Bitcoin network is to build a currency system that replaces fiat money. The Ethereum network's purpose is to act as a platform on which software applications can be built and executed. Next, we will explore this further. On the left are the Lego blocks that constitute blockchain technology. Ethereum provides all these capabilities out of the box. Software developers can build applications on top of it. It is, in that sense, similar to iOS or Android. If a developer wanted to build a currency competitor to Bitcoin, she does not need to recreate anything on the left. Further, currency is only one possible application. Ethereum is a general-purpose blockchain platform while Bitcoin is exclusively designed for currency and payments. In fact, Ethereum was created because the Bitcoin blockchain was built to do only one thing really well and software programmers struggled to build on top of it. In this lesson, we have learned about Ethereum from a theoretical perspective. In the next lesson, we will make it real by viewing some real-life Ethereum transactions. Before proceeding to the next lesson, review the summing up section of this lesson. See you shortly on the other side.